Good evening, Amiga coders. This is Photon of ScoopX again, and we are continuing with making our Amiga demo, or intro as the case may be. So, where were we last time? Well, we've spent some time in Deluxe Paint drawing some graphics. So the last time we coded anything was in tutorial 15. So let's load that. And what we need to do is, of course, to include the font that we drew and copy it with a blitter to the screen. And this episode, or this tutorial, is a sort of a tribute to my viewers. I was a bit shocked seeing that I have over 5,000 views per month. So maybe, maybe this Amiga demo coding business is not as small a niche as I thought, as many others thought maybe also. So this is for you, and I'm gonna have to keep this tutorial short because I've been delayed a little tonight. Someone pointed out that my contact form on our ScoopX site, you can reach it via scoopx.net or scoopx.us or scoopx1988.org. So anyway, that's all fixed now, and let's continue with this. Where were we? Well, let's check where we were. We had made our scroll routine in the middle there, and we will have to do something about that smiley sprite. It's a very happy sprite. I'm sure Uncle Tom would agree, but it looks horrible. We'll see what we can do about that later. For now, we're going to make the lower part of the screen, which is being scrolled, we're going to make that 3-bit planes, first of all, and so that we can display a 3-bit plane font in it, and go on from there. Okay. So first, I'd like to go through the source a little bit. I'd like to replace, capitalize, put initial caps on some labels, because they have been bugging me. I'm using Amiga Shift R or Control Shift R to do this, and if you're replacing common words, then you might want to check what you're replacing there and answer yes or no for each occurrence. We also did a main loop. We had a main. I'm pressing escape to abort continuing the replace operation. So, and we had an init. So what else is there? That's bugging me. Well, scroll it. You can also search for them manually if you know they're one-offs. So that's pretty good, I guess. We also need, well, we don't need to, but sometimes it's nice to have all the constants and includes and stuff in one big file. I thought I'd demonstrate how to make the source smaller. And of course we already did this, but Control W will write a block to disk, and we'll call it Litter register list, and it will overwrite the old file. We already had this file, but either way, that's how you how you copy a piece of your source to a file, then Control X to cut it out and include it back in. So when you're including stuff, I don't know if I've demonstrated this. No, I don't think I have. In some ASM1 versions or under certain circumstances, you need to put at the top of your source one of these so that you get relative paths working for your include files. I don't know if it's a very commonly known thing, but it's good to know. So now our source became smaller, and that's basically it. So I also got some feedback by Jesse Pleb. He noted that I used old open library, and the reason for that is because it saves 2 bytes. That is, if you remember to not clear D0, since it's not needed for calling this function. Because this function, the only code for this function is to clear D0, which is the requirements for the Kickstart version, or library version, I should say, and then call open library. So this is a trick I learned early on, and it's perfectly good for opening any standard library on the Amiga. If you have special requirements for your utility or whatever, that you need a certain version of a library, then you must use open library, which is at another offset in exec library. And then you need to supply the version number in D0, the lowest version number that you require. So for example, version 36 is Kickstart 1.3, version 37 is Kickstart 2.0 for most of the common libraries, standard libraries in the Kickstart. But I digress. Either way, thanks for pointing that out, and we've saved 2 bytes code. I don't know how it got in there. So the next step is to include the binary, and to do that we can use we put it in the media library, and it was called, I'm gonna copy that by typing Control Escape, and we're gonna put it, I think, before the logo or someplace in chipmem. I'm gonna put it between the end of the copper, and why not put a label there as well. Copper, so we call that copper E. It's completely unnecessary unless you need it sometime to check the size of the copper, for example. Then it's easy to type copper E minus copper to get the size. So imaginatively we call this font E, and we include a binary, still using relative paths. Fast car font dot 284, that's the width, 100 3-bit planes, and from this we can set some parameters. The palette will be at the end of this binary, and we may have to add a label when we get to that point to point to the palette, so we can copy it easily to the copper. But for now, we go this way, and okay, so all right. why not clean that up to make nice columns? So anyway, if you're in this control escape mode, then just press escape and then escape again to get the full screen mode. So the first step is to check that everything runs. First of all, we should save this as tutorial 20, since the last graphics tutorial was tutorial 19. And assemble it just so we see it works, and it doesn't, because we forgot the file suffix. Thought I. Are you kidding me? Ah, okay. We need to be in the root directory there, because as I said, the paths are relative to where you are, to the current directory. And if you want to have a base directory, then you could type something like /asm school, like that, and it will still work, regardless of whether you have navigated to another directory than this directory. So let's try that, and it could indeed include all the files. And now the font is the largest graphic in the intro and the demo. So we could have a look at this. The characters are 32 pixels wide, so why not do it like this? And that doesn't tell us very much, other than that we have some sort of graphics there, possibly, if you're familiar with these hexadecimal patterns for solid blocks of graphics. So let's go ahead and find the blit that we used for scrolling, and simply modify that to be a copy blit that copies a character to the screen. But first, let's go. I'm going to put a bookmark here, Amiga Shift 2, for example, and then go to the copper and increase the number of bit planes if we didn't already. No, I don't think we did, right? No, here it is. So we increase that to 3 bit planes, and watch what it looks like after that. And this is not necessary for coding, but it just showing you that the first bit plane pointed to is correctly set, because we set the bit plane pointers below the last raster line of the logo. But the other bit plane pointers continue off from whatever they were set to, showing whatever's in memory after the logo, where we stored the logo. So do you get that? Bit plane, the first bit plane is our bit plane, and bit plane 2 and 3 continues off from the logo, because we haven't disabled them as we did before. So they're now visible and showing the contents of the memory after where the logo is in memory. So to do this, of course, we need to reserve some more memory for our screen. Our screen is now 3 bit planes deep, so we have to multiply the bit plane size by font BPLs, for example. That makes it dynamic. I could have typed 3 here, but of course if we change the font to one with 4 or 2 bit planes, we have to change it all over the place. And this is a good exercise as well, to make this fixed bitplane thingy here. Actually, this could be eliminated because under these circumstances, it just so happens that the logo is the same number of bitplanes as the font, right? So we could comment this out or remove it completely. But for learning purposes, we're going to make this dynamic, and that means that in this position where the number 3 is, we should replace that with whatever font BPLs is set to, right? So that if you change font BPLs, this value should be increased or decreased hex 1000-fold. So it should go like this if it's 2 bitplanes, or like this if it's 4 bitplanes, right? So to do that, we remove this digit, or we can type it like that. It's cleaner that way. And we calculate the value to make it dynamic. So font BPLs times hex 1000 plus, or you can OR them together. Either way, I never use OR. I always use plus. I know what bits I'm mixing, so there are no negative effects. Which is a nice newly released demo for the Amiga 500. Check it out if you haven't. So anyway, that makes it dynamic, and just to check our bullshit, we check that we get the same result as before. We also need to set more than one bitplane pointer, right? Because that's the reason for the trash on the screen right now. So copy that. So as you can see, it's not completely dynamic. If it were, we would have a dynamic number of bitplane pointers here, but there must be limits to the amount of stuff I show you to learn stuff. It should be enough that I mention it. So we now have 3 bitplane pointers, and we set that bitplane pointer somewhere. So we're going to search for this label. And there it is, and we should have a loop around that, right? Do we have a we have one of those for the logo. So why not completely replace this one-off bitplane pointer setting that we have here, and we're just going to keep the destination pointer, so that these are the registers we're using, and we could keep the comments there. So I guess the easiest way is to just copy them like that and remove those, so that it, and we could make that dynamic as well. So I could also introduce maybe a new instruction for you, move Q, which is move quick, and it's valid for values between -128 and +127, and it saves 2 bytes of code and a few cycles. It should save 4 cycles on 68,000. So that's basically it, and we need to change this, right? We need to have some sort of offset here to step to the next bitplane of the font. So now we have that, but of course if we assemble it, well, first of all, we have a double symbol, so we're lazy, we're just gonna increase that. And it complains that this value is unknown to the assembler because we haven't defined it. We're going to define it from the font dimensions. And font BPL equals font width divided by 8, right? Because we saved it in interleaved format. If we had saved it in the linear format, all the pixels in all the bits in each bit plane would have been saved one after another for this many lines, and then you would have entered the second bit plane and third bit plane and so on. So it would have been 100 times higher to step to the next bit plane in this case. So now we have that offset, and what have we done here? We've made an error, right? Because it's not the font bit plane that we should put here, that we should step forward, because it's the screen pointer that we're poking to the copper, right? So we need to take the screen dimensions instead, and those are here. So should we call that like this, and take that with divided by 8 instead. So now we are setting pointers here. We're stepping through 3 bit planes and setting the pointers, and we have reserved 3 times as many bytes for the screen. So that means that now the trash should be gone. Well, sort of, kind of, but it seems to me like we are somehow setting the modulo to something that is wrong. I think we're setting the modulo to 0, which means that the copper itself is not skipping bit planes 2 and 3 to reach the next raster line, as you do in interleaved mode. So we need to correct that. And then we'll use the screen bitplane variable again. Now, simply we should skip 2 bitplanes, and that should be the modulo value. So right, so I'm going to put a bookmark here. And we need to set the modulo values to screen bitplane times 2 to skip 2 out of the 3 bitplanes to reach the next line. And the same is true for the odd bitplanes, both the odd and even bitplanes. And so now you see the image has shrunk vertically, and that is because when we poked these number values, if you remember, into the first bitplane, we only had 1 bitplane, and so it also needs to skip bitplanes in interleaved mode to not put bits in all 3 bitplanes. I don't know if I should care about this. We will certainly need to look at the modulo value for the scroll bit later on. So why not correct that first, because we will need a correct scroll routine to be able to scroll our font. I just don't want to drag this tutorial out so that it's too long, because it's late in the evening and I need to go to bed. Right, so blitz skip is incorrect currently. It too should have 2 bitplanes added to it, right? And let's see if we've thought correctly and that fixes it. Well, it fixes the height of the scroll, I guess. Maybe. So, are we... I didn't look 50 pixels high to me. So what's wrong with it? We skip that amount of bytes to reach the next line, and we add 2 bit planes. What's wrong with that? Are we using it for something else, perhaps? You know what? Why not make this well, I need to think about this. First of all, the corner is now also wrong because it doesn't take into account that we have 3 times as many bit planes. So I think that, and you can see some crap down here, which means the blit has gone haywire. So quickly now, check that the that Amiga DOS is still running. It is. Update the file. Wait a few seconds to let it finish the dreaded index right there, and reset your computer. And load your source back in. So scroll it. Let's go. And we had some sort of blitter offset, and we had some sort of height here that we multiplied with the bit plane width, which is now no longer true. We need to multiply it by one line of bytes for 3 bit planes. So we need to multiply this with 3 times as much. We could hack this, I guess, but I guess the more correct way would be screen bit plane times 3, because that's the bit plane width in bytes, so we don't need to divide by 8, and we have 3 bit planes for each scan line since we're using interleaved mode. And I don't know why I used, I didn't make this dynamic, but let's correct that now. Surely that should be the top coordinate. So, are we using BLTH, summer beer corner, right? We are using this to move down to the bottom right corner. And here too we do the same thing. The factor to multiply by is 1 line of bytes for the interleave screen. And to me that should do it. And we should now at least have a 50 pixel high scroll somewhere in the middle of the screen. Yeah, that looks okay. And as you can see, it only scrolls the first bit plane because that's what we told the blitter before. So we also have a small bug again, the dreaded bit plane pointer there. But I think we can fix that later. For now, we're gonna make the we can make this as dynamic as we want to. We can type font BPLs there instead of a 3. But I get impatient, and now we're gonna just code this thing. I multiply that by 3, and when we do that, we no longer need to skip the extra 2 bit planes, right? Because we are processing all 3 bit planes, and therefore we should skip only hang on, let me think about that. It will blit BLTW words, right? And then it will skip. We've tripled the total height of the blit to be 50 in each bit plane. So that means that we will get some leaking, probably from bit plane to bit plane, but since we will be replacing this leaking that comes in when it wraps from the left edge to the right edge will be okay. So remove the extra skip there. And let's now see if it scrolls all 3-bit planes. Yep, that worked. And again, it's late at night, so I'll give it a try. Why is it bouncing there? Probably the same reason as before. Will we be saved by the bell if we move this down one scan line? Who knows? We actually were. However, I think we need to put a weight here. We get a gap between the two, between the logo and the screen buffer. But if we set the number of bit planes to 0, this is an ugly patch, but I'm a bit impatient, so looking carefully to see if there are any side effects. There seem none. So we've patched this up, and actually now we need one scan line less of a screen buffer. And we've already reserved way too much memory for this, I see now. So what we need is, well, where does it end? Well, you know, let's keep that, because we might want to do something with this screen later on. Maybe we need the extra space. At least that's the thought I had now. So, what remains here? Well, it looks pretty ugly with those random values causing random colors. But why not just, for Pete's sake, blit a character to the screen? We have them here, this address. So we're gonna copy the scroll blit, since it is a copy blit, 9F0. We can use it temporarily just to get a character on the screen, so that we know that all our modulo values for the blitter and screen are correct, that we're thinking correctly. And then in the next part we will make it dynamic and put it in the right place and so on. So, copy the relevant parts. You know, I want to move this to enable Litter DMA, you know, for the whole demo, because, like, we're gonna use it, right? So we have a nice little init here, and I think it will be fine if we set the DMA here. So why not combine these two? However, I'm not sure that A6 is initialized here, is it? We could prettify this quite a bit, I see now. But let's see if it is. So to check if bits are set in the 87E0 value, that are also set in the 8440 value, we OR them together, right? And see if they, if the total amount is then 87E0, then we already enabled Litter DMA in the original setting. So this is a good exercise. 870 and OR it with, I do it so seldom, but yeah, should work. Illegal opera, I knew it. So what the hell was it? This is, whoops. This is exclusive OR, I think. So it must be an exclamation sign. Yeah, it should be. And so let's double check that. Yeah. So we've verified that we already set the Litter DMA. So it was completely unnecessary to have it in the scroll routine there. You seldom need to modify the DMA in a demo, you may want to sometimes, for example, a typical example would be to turn blitter nasty, or I should say blitter priority, on or off depending on your CPU load. If the CPU load is very low, as it usually is, then you should have blitter priority on, and if you and otherwise you should have it off. Whatever pays off the best in rest time, right? So basically we could make a little plot char routine here, and we need to remove the shift from the copy operation, and we no longer need to do it in descending mode. The mask should stay as it is. We need to change the source and destination address, so we need to copy the very first letter to somewhere on the screen. So I have no idea, but we calculated this value times 3, right? And we can multiply that by some constant like scroll y that we will invent. And we need to know what the modulo should be, and that should basically be screen BPL minus font BPL. No, that's not correct. That's for the destination. And that's not correct either. We need to make it screen BPL minus the number of words we're blitting, which is we're blitting 2 words for a 32 pixel wide font. And that's 4 bytes. And in the font we need to likewise, after we've copied 2 words, we need to skip almost the full font bit plane to reach the next bit plane. The blit height is 20 because the characters were 32 by 20 pixels. We're copying 3 bit planes. And by the way, if you're worried about the OR operation there, you might notice it's a pipe sign in some ASM1 versions and an exclamation sign in these early versions that I'm running. So, and the width is 2 words. So we're copying a total of 120 words to copy a character to the screen. So what else do we need to do? We're waiting for the blitter. We're setting the copy operation and mask. We're setting the source and destination pointers. We're setting the correct modulos and the correct blitter size. And all we need to do is define the Y position where we want the character to appear. So this is just a test routine to plot a character, and we'll use this routine later to fill the gaps or put characters in the right hand edge of the screen as they come in, as they are read from the scroll text. So I have no idea, 100 maybe. Let's try that. And belongs together with this, I think. So let's see if it all works together. I would say that is a non-result. because we're not calling it, because I'm tired in the head. I'm gonna search for space scroll it, because I want to find where it calls the scroll routine, and I'm gonna call plot char after that. And we get something that looks crazy, man. So, no question about it, we got something wrong. I got something wrong. You are completely innocent and probably already called me on it. We should check some values. That's strange. That's not correct. Because the number of bytes skipped and so on, or the byte width of any bitmap should never be odd. Should always be divisible by 2. Because they are rounded upwards or downwards to even 16 pixels. So why did we type that wrong? You can check if something is divisible by 16 by dividing it and multiplying it up again, because this is an assembler, so in these older assemblers, all division is integer division, and when you multiply it back up, it takes the integer result and multiply it. So it's incorrect. So likely then it got slightly bigger, right? Or else it clipped the font when we saved it, or I typed the wrong width value. So either way, I'm gonna add one to it. Why am I doing this? There, 288. So it wasn't even divisible by 8. So I just typed the actual width. I didn't type the width rounded up to even words. So let's correct that. 284 becomes 288, and let's see what happens. And I'm standing in the wrong folder again. And that looks much better. Isn't that excellent? Apart from the colors. So as a final exercise for this, let's go to the init and copy the palette. And to do this, I can show you another thing, which is how to set a pointer address to what we want. We could just copy the last 8 words from font E minus 8 times 2, right? But you could also declare a label like this. Font E, 8 times 2, like that. And you need to put this here because font E is unknown to the assembler until it reaches this line that I'm standing on with the cursor. And so this definition is only possible to calculate on this line, and anything that uses it will have to wait for pass 2 to read it, and it usually works. It may be the same thing that we had before when we put fixed addresses in the copper list, if you remember, and if so, we'll have to omit that. But anyway, that's one way of making a temporary variable calculated from labels. So let's go to the init, and we need to put something when all is done here to copy the palette. Do we already copy a palette somewhere? I'm not sure. I think we exported the palette, right, and pasted it into the copy list. To do this dynamically then, let's make a copy loop. Actually, it's a good idea to make a small routine that takes a few arguments that copies from, let's say, address register A0 to A1. It's in this for the previous exercises, then it wasn't usable because we were skipping control words in the copper. But now it is, so why not make a little copy command here. I'm gonna call it copy bytes because it should be a generic copy loop, and to define it I type that looks pretty with commas, so count, source, destination. And basically all it does is copy the source to the destination and decrease the counter. So here again we use subq. Actually it would be even more generic if we used that, right? So that's what it does. I could have used dbf, but then the user of this routine would have to remember to subtract 1 each time from the count. And if you're gonna make a slow generic copy routine, why not make it as simple as possible? So let's step through it. Previously we've used dbf. Now we are manually counting down the d0, the count, by 1, and when it reaches, as long as it's non-equal or non-zero, it branches back and copies another byte, and when it's equal or 0, when it reaches 0, it exits the routine. So now all we need to do is set this, and this is also a new feature. This is PC relative coding, and this saves 2 bytes. I'm not sure I've done it before. And it's generally and it's 4 bytes fast, 4 cycles faster. So if you want, you can use it if it is within reach from the current from where this line is assembled to in memory. So when the processor reaches this line, it looks for an offset to its current position and puts it in A0 as an address. It loads that effective address. That's what LEA stands for. And we're going to poke it to the copper, and we don't have any palette colors in the copper, so let's remedy that and put them there. We could copy some lines probably here. Yeah. So we got 8 colors here, and we don't need to care about. We're going to copy the logo colors straight away, and they will be replaced by the palette appended to the font. And we need to set them before it starts outputting the screen buffer, right? So when do we need to do it? Well, setting the bitplane pointers and modulos and enabling bitplanes is high priority. This has to be done during the horizontal blanking, right? So that actually we should modify this to wait for the last position outside the screen, which is to the right, which is there for a non-overscan screen. And now there's plenty of time in the horizontal blanking to set the palette. And I guess, I don't know, we don't change the background color. So in essence, we don't need to set color 0 here, but let's do that anyway, just to see the effect it has. And we want to call this font pal, right? But we already had a constant by that name. So I'm going to rename the other constant font pal p for pointer, or maybe the other way around to keep it in line with these. It's just a matter of taste. You could call it font colors or whatever you want. So we were here, and all you need to do is assemble this code to see if it is within reach from the CPU, and then of course if you add stuff to the demo, then it may go out of reach. So that's the drawback of using PC relative addressing. But it's good to know, I guess. And we can set the whole long word with a simple move Q that we used before. And how many bytes? We should copy 8 times 2 bytes. And simply call copy bytes. Like that. So, alright. Let's see how that fares if we manage to... Oh! And we can't use the copy the copy loop. And I discovered this after like 5 minutes typing the code for it. You know what? Let's keep the copy code. It's good to have, and it was a good exercise. But just as we have to skip control words when we're setting the pointer high and low words for the sprites, etc., we of course need to skip the control words here as well. So we're going to add 2 to this address to skip the first control word, which is hex 180 for color 00. And we're gonna do it like this. And we're gonna make a color loop, and we're going to move words. I managed to press F10 again because I have these thingies connected to those using set key. So anyway, we're moving words, we're copying words, and we need to add 2 to the destination for each color. And now I can use dbf because it's a special case and because it's consistent with the other loops up there. So let's try that on for size then. And that didn't work. And I think it's the same as before. It's the relative mode error we had before. Namely that the problem is not that it's out of reach, even if it could be. The problem is that this value font pal is set after this in the source and is therefore not available to the assembler to assemble this line in this pass. So we're gonna cop out and put that there because I'm tired and I want to finish this tutorial, and that by golly should work. Remove this, save the source, and please give me the correct colors. Yep. So there we go. So I'll welcome you back beforehand to the next tutorial, where we'll be plotting the characters in the correct place and scrolling them and enjoying a nice little scroll. See you in the next tutorial. Bye for now.